Hello, I am Mert Çelikten and today I will be talking about my final project for Physics 102, titled Capacitance Variation with Plate Separation and Dielectric Materials. The purpose of this experiment was to explore how different dielectric materials and their thicknesses affect the capacitance of a parallel plate capacitor. My goals were to measure the capacitance and thickness of various materials, calculate their dielectric constants, and confirm the theoretical relationship between capacitance, distance, and material properties. The capacitance of a parallel plate capacitor depends on the area of the plates, the separation distance between them, and the properties of the material placed in between. When a dielectric material is inserted, it increases capacitance by reducing the effective electric field. The theory predicts that capacitance is directly proportional to the dielectric constant and inversely proportional to the distance between the plates. First, I built a capacitor using flat aluminum plates. I measured the capacitance with only air between the plates to establish a baseline. Then I placed different materials, specifically styrofoam, wood, and glass, between the plates. I measured the thickness of each material using a digital caliper and recorded the capacitance using a multimeter. For each material, I repeated the measurements 3 times to improve accuracy. Among the materials tested, glass had the highest dielectric constant, with a value of approximately 7.33. Wood had a moderate dielectric constant, around 2.86. Styrofoam showed a dielectric constant very close to 1, behaving similarly to air. Overall, the results confirmed that materials with higher dielectric constant increase capacitance while thicker materials reduce it. Several sources of error were identified. These included slight misalignment of the plates, air gaps between the materials and the plates, the environmental factors like humidity affecting the properties of wood. To improve accuracy, I suggested using alignment guides, applying uniform pressure when placing materials, and performing the experiment inside a Faraday cage to eliminate stray capacitance. In conclusion, this experiment confirmed that theoretical relationships we studied. Capacitance increases with higher dielectric constants and decreases with greater thicknesses between the plates. The experiment also showed that the importance of careful setup and control of external factors when measuring physical properties.